the last session, I'll be discussing about the next thing, which are known as the scalars and the vectors. Okay. So what is the basic difference? What is the basic difference when we talk about a scalar and a vector? Now, when we talk about a scalar quantity, a scalar quantity precisely means the one which does not need any direction to be specified. Obviously, unit has to be specified and a numerical quantity. Apart from that, you don't need to specify the direction. Direction in the sense whether you are moving from left to right, that is whether you are moving from north to south or from east to west, that is the direction you need to specify. Obviously in terms of the rectangular coordinates, the Cartesian coordinates. So that is a scalar quantity. So a scalar quantity doesn't need a direction. It can only be specified by its magnitude and its unit. Whereas when we talk about a vector quantity, it needs direction. So if vector quantity needs direction, it obviously is going to mean that it is also going to be needing the unit and the numerical value. So vector quantity needs three things, scalar quantity needs only two things, right? So this is the basic difference. So generally what we have for any vector, for any scalar quantity, there is generally a vector analog as well. That is the quantity which has the same dimension, mind you. It may be having the same units, but the name is going to be different. One is going to be scalar quantity, the other one is going to be a vector quantity. Let's try to understand a few examples for that. For instance, let's say distance and displacement. Okay. So what is the difference? When we talk about distance, so distance is nothing but the length of the path covered, right? That's it. We do not specify whether the path is covered from east to west, west to north, which direction. Whereas when we talk about displacement, displacement basically implies that it is equals to the length of the path covered in a particular direction, and we also specify that it is the shortest length. Okay, so it's the shortest length of the path covered between any 2 points, and obviously in a given direction. When we talk about distance, it is not the shortest length, it can be any length, it can be variable, even between any two given points the length can differ depending upon what direction or what path you are taking. Yeah? So this is the basic difference. Then if we go ahead and talk about speed and velocity. What is the difference? Speed is a quantity which depends on the distance. So it's a scalar quantity. Speed is what? It is nothing but the rate of change of distance covered per unit time. Okay? So this does not depend on direction, but obviously it's going to be dependent on the path taken and the time taken. When we talk about velocity, velocity is a vector quantity. It depends on the displacement and therefore it's a vector quantity. Further, what we say that the velocity is equals to the rate of change of displacement per unit time. Okay? This was the rate of change of distance, this is the rate of change of displacement. Going further, we have one other quantity, that is acceleration. Now acceleration does not have a scalar analog. There is no scalar quantity which has the same dimension, same units as that of acceleration. Okay? Acceleration is always vector. Please understand that. The reason being, acceleration is derived from force. We'll be discussing more on it when we come to the chapter of uniform motion. So acceleration is defined from force. So when an object is applied, when a force is being applied on an object, in that case the change in its velocity per unit time is what is known as the acceleration. Okay? So this is the basic difference when we talk about a scalar quantity and a vector quantity. So if we go further on that, let me see that how to add two scalar quantities or how to add two vector quantities. So what is the basic difference? So the basic difference comes in okay, so if we first try to understand about addition. So for scalar quantities, if you are given two quantities which have the same dimensions, you can simply add them, irrespective of any direction being specified. Whereas if you talk about a vector quantity, so for a vector quantity, there are two ways of finding out the net result. One is what is known as the triangle law of vector addition. The other one is known as the parallelogram law of vector addition. Okay? So for scalars we should not worry. We should just be concerned about if they have the same dimension, then we can add. If they don't, then we cannot. So if they have the same dimensions, obviously only then vector also we can add. But there are two rules, because for vectors we cannot add them simply. There are two rules using which we can add two vector quantities. So these two rules we'll be starting off with the triangle law in our next session, and that will be followed by the parallelogram law. Yeah, thank you. So the next topic that I mentioned we'll be discussing is the triangle law of vector addition. This is a very important law to be understood. So when we talk about a triangle law of vector addition, what we say that, let's say this is one straight line vector. Please understand that this is a straight line, and there is another vector. Okay. So if I specify that this is my vector A and this is my vector B. Okay. Now, before I go on to discussion of this, I should have actually specified this before. That what is the representation of a vector? So if I say I have any vector R, this vector is going to be represented in three coordinates. You have x, y and z. So along each direction you specify, you have some value of it. So let's say the coefficient or the value along the x-axis is x. The direction is represented as I cap. So I cap is basically you have I cap, j cap and k cap. These are known as the unit vectors along that particular direction. So to specify the x-axis, you say that there is a unit vector. So unit vector just does one thing, it specifies for you as to what is the direction of that particular axis. Okay? So x is the magnitude of that particular axis, I cap is the direction in which it is being specified. Further, we will say that x I cap is there, then we will say y j cap plus z k cap. So this is the basic representation that we have. So x is the magnitude of the vector along the x-axis, y is the magnitude of the vector along the y-axis, z is the vector on the z-axis. If you wish, you can take any other values, doesn't matter. So this is the representation that we have. So when we are saying that we have these two vectors, let's say this is one vector, this is another vector that I have. I want to find out the net resultant of these two vectors. Okay? So the way to do it is that you parallelly move this vector A to itself such that its length or angle should not change, and the tip of the vector A should be meeting the tail of the vector B. Either you move the vector A or you move the vector B. So let's moving the vector B is an easier choice. So assuming that I haven't changed the angle or anything. So let's say this is my vector B. Okay. Further, the resultant, for finding out the resultant, what you will do, you will be starting from the tail of the vector A to the tip of the vector B. So this is your vector C. So this is the resultant. Now, vectorially speaking, it is very simple. We will say that the vector A plus the vector B will be equal to the vector C. Okay? This is using a vector law. But we have to find out the resultant because we do not know what exactly are the values. So we have to find out the resultant. So how do we exactly we are going to do it? What will we do? We'll say that we'll just extend this further. So if we extend this further and say that, let's say the vector B is making an angle theta. Assume that the vector B is making an angle theta with the horizontal. So if I now draw a perpendicular over here, and you can now see that this becomes a right angle triangle. Let me name this right angle triangle. Let's say this point is A, this point is B, here I have C, and let's say this is D. This is the right angle that I have it. Okay. I want to find out what is the value of C, the magnitude of the values. So how to do it? What will we do in this case? We have to take the component of, let's say, the vector B along the horizontal direction. So let's try to do that. So if you try to take the component of the vector B along the horizontal direction, that will be given by what? Basically that will be given by CD. So the CD value is going to be equal to the vector B into the cos theta. So CD is equal to B cos theta, and similarly the value of AD, the value of AD can be given by B into sin theta. Right? So we have CD given to us, we have AD given to us. Why do we need this? Because we need the horizontal value as well. So effectively what will we get? We'll get BD, that will be equal to the vector A plus vector B cos theta. Right? So effectively we will be left with these two choices. So let's try to use this to go further. So removing this, hopefully you will have taken a note of it. So as a result, what will we get? The net result C, I can simply say using the Pythagoras theorem, C square, I can say is equal to AD square plus BD square. Right? So it is equal to AD square plus BD square. So let's try to expand this. So AD value is going to be equal to B sin theta whole square. BD value is going to be equal to A plus B cos theta. Remove this. Right? So if we expand this, so what we get? So if we expand this, we'll get C square as equals to B square sin square theta, right, plus it's going to be A square plus B square cos square theta plus twice AB cos theta, right? Therefore, if I just expand this and simplify this further, so what are we left with? We'll get A square plus B square plus twice AB cos theta. So this is the value of C square, and therefore C becomes equals to root over A square plus B square plus twice AB cos theta. So this is the relation that we have for the case of the resultant. So this is what is known as the triangle law of vector addition. Okay? So if you know the value of A, if you know the vector A, you can find out its magnitude. So how to find out the magnitude, that I haven't told you as yet. So let me tell you that as well. So if I am given a vector A, which is given by something like AI cap, BJ cap plus CK cap, in that case its magnitude is going to be given by square root of a square plus b square plus c square. Okay, so you have to just take each coefficient, square them up and add them, and finally once you are done you have to take the square. So that is what is the magnitude part, and square of this magnitude is this. So here you have the square of the magnitude, the square of the magnitude. This is the magnitude of A, this is the magnitude of B, and cos theta, that is the angle between the vector B and the horizontal. Okay, so hopefully this makes sense. And one thing I should add here, remove this. If I just redraw the figure, I won't redraw it completely. So if I just redraw the figure, so I feel I have, I'll draw a miniature picture of it. So let's say this was my vector A, this was my vector B, this gave me the vector C. I took this angle to be theta, right? So if I want to say, I want to write down in terms of the angle between the two vectors. So this is going to be 180 minus theta, right? Or if I put this 180 minus theta as alpha, this alpha is equals to 180 minus theta, then theta value becomes equals to 180 minus alpha. So you can write down in terms of alpha as well. So cos 180 minus alpha, that is we are in the second quadrant. So this can be rewritten, and you can simply write this as with a negative sign. So what will you get as a result? You will get minus 2ab cos alpha. Okay? In case you are given in terms of the angle between the two vectors A and B. We have taken the angle between the vector B and the horizontal. You can very well take it the other direction as well. Fine? Hopefully this makes sense. In the next session, we'll be starting off with the parallelogram law. So basically that's an extension of this particular thing itself, and we'll be continuing it further with the scalar and the vector multiplication of two vectors. Yeah, thank you. Hello students. So we had discussed in the last session about the triangle law of vector addition. Going further on that, so we'll be now discussing about the parallelogram law of vector addition. Actually, there is not much of a difference between the parallelogram law and the triangle law. Let me explain you why. So if we talk about the parallelogram law of vector addition, again if you just draw the vectors, so let's say this is one vector that we have, and the other vector is like this. We had named this vector as A, this vector is B. If you remember what we had done, we had parallelly transported the vector B such that its tail should match the tip of the vector A. That was the triangle law. Now if you have to discuss about the parallelogram law, so what is the basic difference that we have here? We have to shift, we have to add the two vectors in such a way that either their tips join or their tails join. So here we will be shifting the vector B from here up to this particular point. So let's say this is going to be our vector B. So this is the basic difference between the triangle law and the parallelogram law. So here both the tails join or the tips join, either of it works. Now we need to make a parallelogram out of it. So what will we do? We will draw a line that should be parallel to the vector A starting from here. And similarly we have to draw a line that is parallel to the vector B starting from here. So this is what we will get. Further, this is going to be the resultant vector C. The answer remains the same. The way you proceed, the way you find out the values remains completely the same. There is no difference at all. It's just the way you proceed to do this. Okay? Because you can still see that this is your vector B and this is, so effectively you get the same triangle and effectively the answer remains the same. There's no difference at all. Yeah? Okay. Now you may be wondering, we have discussed about the addition of vectors. What about the substitution of the two vectors? How do we do that? Let me explain you that. let me explain you about the subtraction of two vectors. So let's say I have this vector A and I have this vector B. Okay. Now if I want to find out the value A minus B, that means this A minus B, I can also write it as A plus minus of the vector B. Minus of the vector B means what? That this is opposite to the direction of the vector B. So if our vector B was directed like this, so our minus of vector B is going to be directed like this. So this is our minus B vector. Okay. Now to simplify this, what you are going to do, you are going to shift it completely so that this is what you get. So this is your minus B vector, and therefore the resultant in this case is going to be like this. So this is the vector C. So the vector C value is going to be what? The vector A minus the vector B. Okay? So this is how the subtraction takes place. So addition and subtraction both can be done using either the triangle law or the parallelogram. So this is how it works. Now we go into the next one. That is what is known as the product of two vectors. There are two ways to find out the product. So the first way, let me write that. So the product of two vectors can be classified into two parts. One is known as scalar product, other one is known as a vector product. Okay, what is the difference? The difference lies here that when you are taking the product of two vectors such that the resultant is a scalar, the resultant does not have any iota, I, j, k values, unit vectors, in that case it's a scalar quantity. Whereas if the vector, if the resultant does have I, j and k values, in that case it's a vector. Okay, so let's try to see how it works. There are completely different ways of finding out, and they have completely different physical interpretations as well. So how to relate that? So when we are trying to first do, the first one is what is known as a scalar product. So let's say I have one vector A out here, I have another vector B out here. The vectors are making an angle theta between them. If I want to find out a resultant of, a dot product of this, that is what the scalar product also means. It's a dot product that we have. So what we do in this particular case, we take a projection. We can either take a projection of the vector B along vector A, that is, we draw a perpendicular from here. Therefore, this particular value becomes equals to B cos theta, and therefore the product, this is represented like A dot B, the product in this case is going to be equals to the magnitude of the vector A, the magnitude of the vector B into cosine of the angle, because when we are taking a projection of the vector B along the vector A, so this is what is the value B cos theta. So effectively this is the dot product. Okay. You may say that why we can't take the projection of the vector A on B. You can similarly do that. So if you take a projection of the vector A on B, so this becomes equals to A cos theta into B, and therefore I can simply also write it as modulus of A cos theta into B. So the result again comes out to be one and the same thing, that is A dot B is just equals to modulus of A into modulus of B into cosine of the angle between the two vectors. So this is simply the value. This is the formula of the dot product. Okay. Now how to find out the resultant? I have already told you how to find out the modulus or the magnitude of any particular vector, right? So let me now tell you what are the values. what exactly is the value of A dot B? If you are given two vectors, if you are not given the angle, if you are given two vectors, then how do you find out the value of A dot B? Let's say that I have a vector A given by A1 I cap. Let me remove this formula blindly. So if I remove this, so A1 I cap, A2 J cap, A3 K cap. Okay? Then, if I require to take the modulus, let me first tell you that as well. So this will be given by A1 square plus A2 square plus A3 square. Right? This is the modulus. Similarly, if I take another vector B, let's say, B is given by B1 I cap, B2 J cap plus B3 K cap. You can, in a similar way, you can find out the magnitude of this. Now, if you are trying to find out the dot product, A dot B. So when you try to find out the dot product of A and B, so what you see, you have to take a product. These are three values. Similarly, these are three values. So you have to just multiply as it is. So if you do it, you will get different values. But what I am only going to be writing it here is A1 B1, A2 B2, and A3 B3. Why so? Let me explain. Let me explain. So if I say that these are my axes, right? So if I say these are my axes, three different axes. So let's say this is my x-axis, this is my y-axis, this is my z-axis, right? So if I take any vector here, so let's say this is the vector x I have it here. And similarly, it can be unit vector as well. Or I can take y j cap here, or z k cap here. So these are the three directions, three values. Therefore, if I want to take a projection of this x along y direction, if I take a dot product value should be 0. Why? Because the angle between these vectors, that is I and j, j and k, k and I, is 90 degree. Therefore, cos theta values are going to be 0. So, what will we have? We'll only have I dot I, that will be equals to j dot j, that will be equals to k dot k. Each has a magnitude of unity. So when you are taking the dot product, you are basically superposing both the vectors along the same direction. So all of these will have a value 1. Rest of them are going to be having a value 0. So as a result, when you try to multiply, you get A1 with B1, because I dot I, these are the vectors, so I dot I will be 1. Similarly, J dot J will be 1, K dot K will be 1. Therefore, this is the resultant that you will get. Right? So this is what is the dot product or the scalar product of two vectors. As you can see, there are no vector components involved here. Right? So this is the scalar product. Now let's move on to the next one, that is the vector product. Let's see what that is. Let me try explaining that. So when we try to talk about the vector product is going to be defined like this. The vector product will be given by, let's say I have the two vectors A and B. Okay. Then the vector product is going to be defined as A cross B. So this A cross B vector, so if I say this is my resultant vector, assuming that this does come out to be the vector C. So this vector C is going to be perpendicular, please understand it. So this vector C is going to be perpendicular to both the individual vectors A as well as the vector B. Okay, this is how it is worked out. So that's the reason we say it's a vector product. So this vector has a direction that is perpendicular to individual vectors A and individual vectors B. Right? Therefore, how to do this? This is given by a relation the magnitude of this is given by AB sin theta, but the direction is not that easy to find out. The direction is going to be perpendicular to both A and B. So if I say that the direction is specified some other vector, unit vector not. So this is the formula. Now if I have to find out the result, so how do I do it? So here we will be utilizing a concept that is known as determinants, which you study in mathematics. So if I say that the vector A is given by A1 I cap, A2 j cap, A3 k cap, and the vector B is going to be given by B1 I cap, B2 j cap, B3 k cap, right? So the cross product, that is what is also known as, so A cross B, we write it like this, that is first we place I, j, k, that is the unit vectors, then whichever vector is the first one, that has those components have to be placed first, so let's say A1, A2, A3, then the components of the second vector, that is B1, B2, B3, okay? And what is the resultant? Let me write down the resultant of these two vectors. I am erasing this. We have taken a note of it. So, if I have to expand this, so this goes as, so when you are expanding with respect to I, you just forget about this column and this row. So what you are left with this particular part. So I cap with, you should have A2, B3, B2, sorry, this should be A3, this is B3, then with J cap. So the rule goes as, first you have a plus sign, then it's going to be a negative, so it's an alternating positive and negative. So the next one is negative, so you get, for J, we forget about this column and this row, okay? So what are you left with? A1, B1, A3, B3. And then you have for K, you forget about this column and this row. What are you left with? A1, A2, B1, B2. Right? Let me expand it now further. So what will we get as a result? I cap here. If we expand, so this becomes equals to A2, B3 minus A3, B2 minus J cap. So it becomes A1, B3 minus A3, B1 plus K cap. So it will be A1, B2 minus A2, B1. As you can see, these are just the components, right? So these are going to be just numerical values. But here you can see that you have I cap, J cap, K cap. So that is the reason we say that the resultant is a vector. So this is the resultant of a cross product. Cross product is a vector, dot product is a scalar. Now what are the physical applications? You find out the energy. How do you find out the energy? You say that when the force is in the same direction as the displacement produced, we say that the energy is maximum. So that is what involves the dot product. Whereas when you are trying to move something, let's say circular path, obviously in that case you need to define something that is perpendicular to both the radius and the force. So that is what is known as a torque. So torque is perpendicular to both the radial vector as well as the force vector. In that case you need to utilize what is the cross product. So cross product is here, the dot product we have already defined, right? So on that note, we end it here and then we start off with the next thing, that is error analysis.